we're now going to extend this idea from example 1. It's going to look very similar, but we have to do a little bit more work. You can see I already talked about this, the idea of reciprocal functions. They're not inverses. We'll talk about what the inverse functions look like. They are reciprocal functions, meaning that cosecant is the same thing as 1 over sine, secant is the same thing as 1 over cosine, and cotangent is the same thing as 1 over tangent. Okay, so now using kind of the same idea as we did in example 1, we're now going to look at example 2, which states if sine of b is equal to 5/8, find the exact values, I don't want decimals, of the 5 remaining trig functions for b. And we're actually going to do all 6 of them, even though they gave us 1. So remember, if all they give me is sine of b, remember sine of an angle measure is equal to the same thing as the opposite over hypotenuse. So I'm going to say I have angle B somewhere on a right triangle, and I know that the opposite side length in here is 5. So opposite of B, I have a side length of 5, and 8 would be considered my hypotenuse. The hypotenuse is across from the right angle, so we would say that this is 8. I also need to figure out what is the adjacent side. So I need to find this value right here. I'm going to call it A. And we can do that by using the Pythagorean theorem. So A squared plus 5 squared equals 8 squared. And when we solve this, we would get A being equal to the square root of, it would be 39. And I don't want a decimal, so I'm going to leave it as the square root of 39 in this case. So now I'm going to get rid of this A, make that square root of 39. And now I want to find all 6 trig functions off of this. So I want to find sine of B, cosine of B, and tangent of B. Sine they already gave me. Sine, remember, was opposite over hypotenuse. Everything is related back to B. So opposite over hypotenuse would be 5 over 8. Cosine of B, that's your adjacent over hypotenuse. Adjacent is square root of 39. Your hypotenuse is still 8. And then finally, tangent of B, that is going to be your opposite over adjacent. So opposite over adjacent, we would have 5 over the square root of 39. And I don't want to leave it like that. I want to get the square root out of the denominator. So we're going to take times the square root of 39 over the square root of 39 to get us 5 square root of 39 over 39. Okay, then off of that, we can find cosecant of B, secant of B, and cotangent of B. Cosecant, that's coming off of sine. Remember, sine is opposite over hypotenuse. Cosecant is hypotenuse over opposite, so we would have 8 over 5. Secant now is going to be, instead of adjacent over hypotenuse, we're going to have hypotenuse over adjacent. So 8 over the square root of 39. Again, I don't want it like that. It goes back to the same idea as what we did down here. Multiplying by square root of 39 over square root of 39. It's going to come out to 8 square root of 39 over 39. And then for cotangent of B, you can use either the purple one or this green one to come up with the cotangent. I'd recommend using this purple one over here, because this is stating now opposite over adjacent. I want adjacent over opposite. So when I flip it, I'm going to get square root of 39 over 5. You would get the same answer if you use the green one, but you're going to have a lot more work and a lot more simplifying to do, which makes it a little bit harder. So I would go back to the original one. That's why I always write down the originals first in case I have square roots. But there would be all of your 6 trig functions.